Thank you. It's good to be here with you today, virtually that is. There have been a number of advances in satellite technology. And one of the questions that one needs to ask, how do you build a business out of Earth observation? Because at the end of the day, it needs to satisfy customers, and it needs to be profitable enough that it can continue to reinvest in ensuring that capability is around for the future. So I'm going to talk to you about some of the key factors that go into deciding how do you build a business around Earth observation. And there are three key things that a satellite constellation needs to have. It has to have a product market fit, because after all, if it doesn't have customers, it doesn't have a business. It needs to be adaptable because satellites last for a certain amount of time. They'll last for years on orbit. And if you guess wrong, you have a bunch of orphaned assets in space that can't be used for something else. And it needs to be capital efficient, which is a fancy way of saying that it has to be able to generate more revenue or more profit than it costs to replace the constellation. So let's talk about product market fit. I'll use a few examples throughout this talk of companies. One of them is Planet, and they came up with a really interesting idea, which is the Planet Dove. It has 3 to 5 meter resolution, and the constellation offers daily refresh. It's technologically very sophisticated, being able to put a lot of capability in a small package. Does it have a product market fit? Well, if you look at global agricultural land, it's about 11% of the land surface area of the planet. People, on the other hand, live on only maybe 8%. And they're actually much more concentrated than that. The global urban land area is about 0.6%. So over half the world's population lives on less than 1% of the land. Now, why is that important? Well, if you look at where the most frequent change occurs, it's unsurprisingly where most humans live. What you can see in this map, this is of the United States, the population density graph correlates very strongly with the change density. So let's take a look at what you can see with a 3 to 5 meter resolution image. Here's a Planet Dove image of a wildfire area. Here is a Sentinel-2 satellite image. Sentinel-2 has slightly lower resolution, but you're getting about the same amount of information, and Sentinel-2 is free. Here is a Maxar image from GeoEye-1, and you can see a much higher level of detail. In this case, you can see the fire trucks in the burn area. And with WorldView 3, the shortwave infrared, you're actually able to see through the smoke. Here's a more recent example. This is the Ever Given that was grounded in the Suez Canal. You can see a Sentinel-2 image. You can see that there's a ship that's grounded in the canal. Here is a Planet Dove image. You get a little bit more detail. Here's a photo that was taken out the window of the International Space Station, so to speak, roughly 3 meter resolution. Here's a black sky image at 1 meter resolution. Here's an Airbus Pleiades at 70 centimeter, looking a little bit off nadir. And here's a Maxar 30 centimeter image, where you can see the level of detail around people who are trying to extract the tanker from having run aground on the side of the canal. So which do you think is more useful? Well, what about that magic enhance button that you see on television shows, where they use artificial intelligence to somehow magically pull detail out of low resolution imagery? Well, we're familiar with the ability of our phones to recognize our face. But what if our face is on the other side of the room? There's just not a lot of detail there for the phone to recognize your face. That's how many pixels would be across the image of your face taken from the other side of the room. Is this the same person? Nope. How about this? It's not even a person. Well, that high resolution is necessary for artificial intelligence to be able to pull detail out of an image. And you can see on the right the accuracy with which AI is able to pull out detail from closely spaced cars at 60 centimeter resolution versus 30 centimeter resolution. The ability of AI to pull that detail out is much better. Now you could say, well, I can detune the AI so that it recognizes any kind of an object, but you have no guarantee that it's a car, and you're back to the Mr. Potato Head problem. So at the end of the day, is a satellite constellation that can collect 3 to 5 meter resolution on a daily refresh basis enough to build a business? Or is it a niche application, which is technologically very interesting, but never really took off like the Segway? Let's take a look at adaptability. We're familiar with Iridium. When it got introduced a number of years ago, they spent billions of dollars putting up a satellite constellation for satellite telephony. And the company went bankrupt because it didn't have the ability to adapt to terrestrial infrastructure that had effectively supplanted the use case. And it took a very talented management team to turn the company around, pivot, coming out of bankruptcy, and then to deploy a new satellite constellation that was much more tuned to a set of adaptable use cases around the Internet of Things. So let's take a look at another Earth observation company, BlackSky. The promise of BlackSky is 1 meter to 75 centimeter resolution, revisit 40 to 70 times per day. How many unique points per day can a constellation like that collect? So let's take a look at the top 5,000 city centers. If you compare BlackSky, the planet Skysats, which we'll talk about a bit later, and the Maxar constellation, you can see that there's just not a lot of unique points per day that a BlackSky constellation is able to collect. Same is true with the planet Skysats. Why is that? Well, if you were to compare a Smallsat versus WorldView Legion, which is Maxar's next generation system, the Smallsat has a much smaller aperture. And so as a result, the area over which it's able to get a given resolution is much, much smaller than the larger aperture flying at a higher altitude. So let's take a look at the area on the ground that is covered. The larger aperture is able to collect the same resolution over a much wider area. So now if we look at the orbital path of a Smallsat, it's only going to collect that area when it's in the dotted circle in the middle. If you look instead at a Maxar WorldView Legion satellite, it can collect that area at the same resolution anywhere in the larger circle with 25 times as much imaging time per satellite versus the Smallsat. Well, let's say that we relaxed the resolution requirement so that instead of being 1 meter resolution, it's 1.5 meter resolution. The Maxar constellation still outperforms the large constellation of Smallsats, and it's because of that access area advantage that you get with the larger aperture. In order to get that, of course, you need big optics, and these are the optics that you see on WorldView Legion. Obviously, in addition to being able to get revisit, you need to be able to get data in the hands of users quickly, and we, of course, provide that. Our median delivery is under an hour from collection to delivery for priority orders. We've done it as fast as 11 minutes, and we've demonstrated the ability to get data in the AWS cloud in under a minute. How about area? In other words, not just collecting individual points, but collecting large areas like, say, a metro. Metros are typically hundreds to several thousand square kilometers. Well, BlackSky turns out not to do terribly well compared to the Maxar constellation. And why is that? Well, by the way, tilt your head to the left. Rotate your head 90 degrees to the left, because north in this image is to the left. This is an image of the Washington, D.C. area. And a WorldView Legion collects the entire area that you see in this image. The framing Smallsat, which is a BlackSky satellite, only collects an area that's not even the size of Dulles Airport. So the problem is that you're looking at the world not just through a soda straw, but through a cocktail straw. So which one is more adaptable? And by adaptable, I mean able to deal with a range of circumstances. How does the market demand change over time? How does the market vary geographically as a function of where you are looking on the Earth? Adaptability in this context means that you've got higher asset utilization. Your satellite assets are able to generate revenue more of the time as opposed to spending a lot of their time idle. And it means that you're more resilient to changes in demand over time, because our ability to predict the future is imperfect, even in the best of worlds. So if you look at the ability to collect large contiguous areas or a mix of area and points, high resolution to serve more use cases like we talked about with the AI example, and the ability to collect more points per day, Legion wins in all of those areas. Let's talk about Revisit. Airbus is offering to launch this year the NEO constellation, which they say will offer 30-centimeter resolution. It's a total of 4 satellites that are in sun-synchronous orbits. They're phased in such a way that they'll get at least twice daily revisit. You compare that with Legion. So Legion is in a mix of sun-synchronous and mid-inclination orbits. So sun-synchronous orbits, think of them as going over the pole, and they're seeing a point on the Earth at the same time every day. Mid-inclination orbits are not in that sun-synchronous orbit. Instead, they're at an angle, and so they are able to see a point on the Earth at different times in the day, because instead of being locked to a single time, the orbit will phase relative to local time. So if you compare the NEO constellation with 4 satellites, and we're looking here at an example of 1 meter resolution, so 1 meter or better, so the ability to look off nadir to get 1 meter resolution or better, you see that the NEO constellation will get about 4 daytime accesses. Planet does better. With the 21 satellites, they get about 7 daytime accesses. Maxar's current constellation is in sun-synchronous orbits, but with the addition of 6 Legions, we'll get 13 daytime accesses spread throughout the entire day as opposed to at fixed times of the day. Let's now take a look at capital efficiency. So capital efficiency you can define as the annualized profit or EBITDA divided by the annualized Capex. That's proportional to the amount of capacity that you can monetize divided by the annual Capex. So let's take a look at a comparison. First of all, Maxar is improving its capital efficiency with the Legion constellation. If you look at the dollars that we had to spend for the first 2 generations, the WorldView 1 through WorldView 4, including GeoEye-1, 6 Legion satellites for a small fraction of that. In fact, 60% less Capex, 50% more total capacity. And it's more valuable because with the mid-inclination orbits, we get roughly triple the capacity in the high-demand areas. And because of Legion's resolution at 29 centimeters, we get triple the capacity at 30-centimeter resolution as well. So it's roughly 10 times more capital efficient than the prior generation. But how about compared to alternative approaches? We all hear, for example, that Smallsats are very inexpensive individually. So how does an inexpensive individually Smallsat compare in capital efficiency to a Legion, which is, as you can see, $600 million for 6 satellites. It's not exactly cheap, certainly a lot less expensive than the prior generation. So let's take a look at Planet. The Skysats, you can see here the data that the Skysats are able to collect, about 400,000 square kilometers a day with 15 satellites, and that's from the Planet website. So let's see how that compares in terms of ability to collect area. Today, the current constellations, the Skysats collect 400,000 square kilometers a day compared to Maxar, which is capable of collecting over 3 million square kilometers a day. And as Legion comes online and the remaining Skysats get launched, the number increases somewhat for the Skysats, but Maxar is running at well over 4 million square kilometers a day, probably close to 5 million square kilometers a day. Now, Planet has talked about lowering the altitude of the Skysats so that they can collect 50-centimeter resolution. Well, what that does is it reduces the area collection capacity even further because closer to the ground, smaller scene size, less ability to collect area. So let's compare the capital efficiency. Let's normalize so that we say 50-centimeter to 50-centimeter collection capacity. 1 Legion turns out to be about 75 Skysat equivalents. If you think about the charts on the previous slides, when you figure out how many square kilometers a Skysat can collect versus how many square kilometers a Legion can collect, it's 75 to 1. Legions are designed with a 10-year life. Skysats flying at 50 centimeter are so low, they have much less than a 5-year life. We've talked about publicly that Legions cost $600 million for the first 6. It's been reported that Skysats have an average unit cost, including amortized development cost, of about $5 million a satellite. So doing the math, you get an annualized cost of less than $10 million a year for Legion and something like $75 million a year for an equivalent capacity from the Skysats. So Legions are at least 7.5 times more capital efficient than Skysats, even though the Skysats are technologically interesting, a small satellite, inexpensive, that's capable of doing moderate resolution Earth imaging. If you look at the collected area per day, now let's compare several of the constellations. This is the amount of area that can be collected per day over the Toronto area. And you look at Maxar today with the addition of Legion and comparing that with Planet and Airbus, you can see that Maxar is substantially more capable over that area. And this is for 50 centimeter as well as 1 meter access. So, moral of the story, when we build roads, we don't build them with hand trowels, even though hand trowels are less expensive. We use bulldozers because they're more capital efficient. And why is that? Because the more capital efficient business can offer you a higher quality product at a lower price. And that's what we're doing with WorldView Legion. And you can see here photos of Legion under construction. In the upper left-hand corner, you've got a couple of the satellite buses that are waiting for installation of the instruments. The bottom left, you can see the telescopes that are being assembled into the full-on instrument that you can see on the right. And with that, thank you very much.
Hello, Maxar. Hi, John.
Good morning, good afternoon.
Hi, Chris.
Hello.
How are you both today?
Doing great.
Great. Thank you for being here, and thank you for Maxar being a gold sponsor of GeoIgnite. We appreciate it. It's your 3rd year with us. It's always excellent content and information. That was an interesting and provocative discussion from your CTO. I don't think I've seen a talk like that before. Very exciting to have it in the conference. We've got a question already in the Q&A. I'd encourage all the participants, please use the Q&A tool for questions about the presentation or in general Maxar. So let's start. The first one is from Dennis, and Dennis asks, what types of customers need or want this level of resolution?
I can start off. John, thank you very much. And to everyone on the phone, hopefully enjoying your lunch, brunch, or breakfast, and happy Earth Day to everyone. I believe today's Happy Earth Day. And I think the resolution, and we talked yesterday when David Belanger talked about the Arctic DEM, that was all done in high resolution imagery to the University of Minnesota that was released by the Canadian government. But I think when we're looking, as Luc Brulé talked about 21st technology, and yesterday Ryan was talking about multi-view and 5G applications with higher resolution DMs for not only Canada, but the cities. So the high resolution, we're getting a lot. I mean, whether it's the 5G, monitoring houses, house builds, and the great thing about the Legion is we're looking at, dawn to dusk. So it's going to open other applications as well. Our satellites now are at 10:30 and 1. And you look at Canada with a short tasking season, I think when we want to solve big problems, we need a higher resolution. And we're seeing that in the market. We've had tremendous growth in Canada over the last year or two. I don't know, Chris, if you want to add anything to that as well?
Yeah, we've seen huge growth in the 30 centimeter market from both government and commercial users. Obviously, government from defense to local and provincial governments interested in all sorts of different applications, from even tax assessment, agriculture monitoring. The applications are numerous. I think one of the important things that Maxar's bring to the market is moving the paradigm from and shifting the market from the 50 centimeter and 1 meter resolution down to 30 centimeters, becoming the norm.
It's impressive. I started early on in my career doing aerial photography, shooting 25 centimeter and 10 centimeter resolution data out of the back of a Cessna hanging out the side. And you guys are getting there a lot safer than I did it 20 years ago.
Yeah, and John, to give you a Canadian example, just one for a higher resolution. I mean, there's a lot in the Canadian government talking about whales, the right whale monitoring. We did a project in the summer where they did 30 and 40 centimeter data in the Arctic with a short tasking season. And we didn't really have enough 30 centimeter capacity, but we used our HD technology, which basically produces a higher resolution experience image from our 50. So we completed the project based on that. So there is a huge demand and a growing demand for higher resolution imagery. And to Walter's talk about AI, and Eric mentioned, I believe, the last discussion about monitoring equipment. I mean, what are we going to do there? That high definition, and we're limited by capacity and revisit time. And Legion's going to solve a lot of those problems and create new solutions. As we were talking yesterday about, solutions and problems and solving these problems.
Yeah, that's really interesting. In Will Cattle's talk about the geospatial product trap, I think that which is what you're referring to, it was the idea that there's a lot of satellites going up and then people trying to figure out, okay, who can use this? Who's this useful to? Which is solutions looking for problems to solve. I think that the talk that we just saw from Walter, you can see the utility and the breadth and scope of the Legion constellation. It's very exciting. We have a question from the participants that I'd like to get to. I'm going to mark it to answer live. For either of you, it's from Peter. Hi, Peter. Thanks for being here. I asked this question admitting I'm completely unfamiliar with high-res based commercial market. Given existing commercial products, how does swath width decrease the product value? As you increase swath, you decrease nadir view, so increase likelihood of shadowing what you want to see.
Yeah, I can answer this. And so and part of Walter's talk was also not only the field of view that would be within the swath width of the satellite itself, but the field of regard is one of the important aspects that Walter discussed. And that would be the total visible range from any given satellite in its orbital path. So, think of it as, being able to fly over British Columbia, but see Alberta from that orbital point of view. So it gives you more access points or more ability to see greater areas with your swath width from any given orbital path, being at that higher altitude and having a bigger field of regard that you can actually image within, compared to being in a lower altitude and being fixed to a much smaller pinpoint that you could see with a smaller satellite.
Anything you wanted to add, John?
I know, exactly. To Chris's point, sometimes you want a nadar image, more accuracy. And then for DNI or for the other applications, you want an oblique view or for disasters. We talked about the SWIR hotspot mapping, but there's a lot of applications where you want for emergency response, a full range, a larger swath. When you lower the satellite's altitude, you're reducing the swath and the amount of area that you can actually collect. So there's a definite balance between swath width and GSD resolution.
All right, going back to the Q&A from Xenon. What will be the shortest delay from order to delivery for the Legion constellation? Considering cloudless conditions, are you planning on using AWS ground stations to provide some sort of of near real-time imagery?
Yeah, so Maxar and formerly DigitalGlobe created a large ground station network throughout the world, including both in the Arctic and Antarctic regions, as well as equatorial ground stations. So the time delay from accessing actually collection to downlink to processing can be as short as like an hour, depending on how close we are to an actual ground station. So, you know, if you are imaging, capturing and downlinking at the same time, that time could be incredibly short. So again, it depends on your position from a ground station, but we do own and operate a large network of ground stations all throughout our rev range, all throughout the world. We do leverage AWS for cloud infrastructure to process and get a lot of our data online quickly, and it is an important part of our workflow. But we actually own and operate our own antennas that downlink from the spacecraft.
Well said. Okay, I'm going to mark that one as closed. There's a question from Dennis. When will Legion be available to the market?
So we have our first block of satellites slated for September of this year. And then there will be a commissioning period after that. So we're anticipating it in Q4 of 2021 as we get closer to that or market availability of those products in Q4 2021. So as we get closer to launch and commissioning, we'll have more details and hard numbers as far as our dates. But that would be kind of our general guidance at this point.
Thanks. So during the course of the last 2 days, we've heard a lot of updates from government, the Canadian Space Agency, the SPEO. This morning, the Vice President, Luc Brulé, talked about private industry being a part of that. Has Maxar engaged in any way with that, the strategy, or is that something that's going to happen in the future now that some announcements have been made? Anything you can tell us about that?
Yeah, I mean, at the current state, we've had an NMSO for over 10 years with the Canadian government. I mean, there's been a lot of data exchanges. Maxar, US companies, always had close relationships with the Canadian government. And I think you're looking at the RCM and RadarSat. I mean, there's a lot of combination, tipping and queuing, combining optical and radar. I think it's quite a huge opportunity for Maxar and the Canadian government, along with us and other providers, to build these relationships and partnerships. I mean, I just see it as we can solve more problems, we're gonna have more possibilities and more discussion with the Canadian government. And I really liked Mr. Brulé's discussion on the technology, AI, the cloud, 21st century technology, because I mean, with Legion, I mean, the three things that we wanted to solve with Legion was continuity with our WorldView sensors, more access or capability, capacity in high demand areas, and revisit time. So I think you have a real 21st century technology. And you can imagine if you want to monitor traffic in Toronto, well, you have morning, dawn till dusk acquisition capabilities. So I'm really excited, and I think we all are, with this, the new Legion constellation that's being launched.
Absolutely. It's very exciting. Can't wait to start seeing some of the data coming out of that. Before we wrap up, I was wondering if you could tell us a little about your workshop next week in the workshop week.
Yeah, thanks. So we have currently we have 125 petabytes in the cloud, and we have a platform called SecureWatch. And one of our product managers, Jake Dickinson, is going to discuss the application of SecureWatch. How do you quickly access that 125 petabytes of data? And I mean, it could be monitoring the north, it can be urban applications. There's a number of different layers on there. We have mosaics. There's some quick processing on it. You can do HD or a high definition product, and you know, cloud ACOMP on the data as well. Chris, anything you'd like to add on the SecureWatch? And that's next Monday for everyone interested.
Yeah, SecureWatch is as I mentioned earlier, our use of AWS SecureWatch is built completely within the AWS infrastructure. So as we downlink imagery from all of our assets in space, it's quickly processed and provided to users online in a very quick manner. So through that SecureWatch, either the user interface or through our API integration, users can get access to that data as we collect it globally.
Excellent. Yeah, I highly encourage anybody who's interested in that to sign up. It's a free workshop. John, Chris, thank you very much for sharing that presentation from Walter. It was very interesting.
And John, Walter had a conflict at this time. He couldn't make it, but he sends his regards and thank you very much for the opportunity to talk at GeoIgnite. And thank you for all your work as well.
Yeah, he made the talk especially for the conference. We appreciate that a lot, and we appreciate you both taking the time to be here for this Q&A. Everybody, we've got a 30-minute break coming up, so everybody can get a bite to eat, make some calls, do a little work, so you can come back after that. And we've got a talk coming up about analyzing Canadian communities with POI data from one of our fantastic sponsors, Safecraft. So I'm going to take us out to the break. Thank you both very much.
Thank you very much. Thanks, Chris. Thanks, John. Thanks, everyone.
Thank you.
Bye.